I'd like to do one problem that involves finding the frictional force on an incline. So we're going to say that you're at a water park and your dad, who has a mass of 90 kilograms, slides down a slide that has a coefficient of friction of 0.05 and is at an angle of 25 degrees. I am asking you what frictional force impedes your dad as he slides down. So for this example, you're gonna have to use your imagination a little bit for my drawing. We're gonna say the box there is your dad, and that blue part down there is the water, and the red slanted thing is the slide. So there's a few things that we can find out pretty easily. The first thing we can figure out is we can figure out the vertical force. So the vertical force is going to be this downward force right here, which is also the force due to gravity, or Fg. And we know that Fg is going to be equal to your dad's weight, which is 90 times 9.8. And you can write that as 90 times 10, that's fine too. We end up getting that the force due to gravity is 882 newtons. This is supposed to be a G, by the way. So that's our first force that we know. The next thing that we are going to need is our normal force. The normal force is actually a little bit harder than what you would think. So if he was on a flat surface, the normal force would just be the same as the force of gravity because he'd be pushed straight up. However, he is not being pushed straight up. He's being pushed in this direction. So our Fn right here is that green vector there. So we need to figure out that force. Once we have that, then we're going to use the formula. The force of friction is equal to the coefficient of friction times the normal force. Once we have the normal force, we will be able to easily find the force due to friction. However, finding the normal force is actually pretty involved. So this problem is kind of similar to things that we've done in the past where we break things up into horizontal and vertical components. However, I want you to notice that we already have a vertical component, and we're actually trying to find something that is not vertical, our normal force. So what I'm going to do is I am going to break this up into two forces. So the first force that I'm going to find is I'm going to call it my perpendicular force. You'll notice that I'm using a new notation. This is an F, and the subscript of that is like the two little perpendicular lines. So this is the component of Fg that is perpendicular to the slide. I'll show you in just a minute how to draw that. The second one is going to be, again, a new notation. It looks like a little 11, but that's actually two parallel lines. This is my parallel component of Fg. So Fg is already vertical. Before we did vertical and horizontal components, you actually can do components in any directions. It doesn't necessarily have to be vertical or horizontal, as you can see here. And I'll show you how to draw these in just a second. So this is similar to some problems that you've done in the past. We're going to be using the parallelogram rule, except we're going to be doing it kind of backwards. So the perpendicular component is going to be kind of in that direction. I'm actually going to just kind of draw it with dotted lines. I know it's going to be like that. That is perpendicular to the slide. That's the one that actually is going to be equal to my normal force. And I'll write that too, because that's an important thing to remember. The other component is my parallel component. That's going to be the one that goes in this direction. And that doesn't look completely parallel, but it should be kind of parallel to that slide. So now we have to use the parallelogram rule, but in reverse. So I am going to kind of draw an imaginary parallelogram here. And then I'm going to use that. I'll fill this in. These are going to be my vectors. So this right here is my perpendicular vector, my perpendicular component. Remember, it's not perpendicular to Fn, it's not perpendicular to Fg, it's perpendicular to the slide. And then this one right here is my parallel component. So I didn't draw this perfectly. The size of F perpendicular and Fn should be the same. The Fn ended up being a little longer. I can fix that now if I can erase that a little bit now that I actually know what it's supposed to look like. If your drawing isn't perfect, that's fine, but it sometimes helps just to get a basic idea of the sizes. So we can find, I'm going to actually show you how to find both your F parallel and F perpendicular, but we only need to find the perpendicular one to do this problem. And in order to do that, I'm going to redraw this. So my F perpendicular is right here. My FG is right here. And this thing right here is, that's my lower part of it. I want you to realize that this yellow line is actually parallel to the ramp, which means that this perpendicular vector is also perpendicular to the yellow line. That's the bottom line right here. That's the one that goes along with this thing. So that is a right triangle. So I have the FG. I know that that's 882 newtons. If it's bothering you that this triangle is kind of sideways, you're welcome to redraw it so that it's not sideways. I think a lot of people like to see just a standard triangle. So it looks like this. I think one of the things that's hard for people on this is figuring out what any of the angles are. If you use geometry, one thing that you will find is that this angle right here is going to be equal to 25 degrees. There's a whole bunch of different little geometry theorems that you probably have seen in the past. If you took geometry, if you didn't, you don't even really need to worry about that. But you can just trust me that this angle right there is equal to the angle that you have right here. You don't really need to know why. If you want to know why, though, make sure that you take geometry at some point, which I think some of you have taken it. Some of you are in it right now. It doesn't really matter if you haven't taken it. You can just remember that that's the same angle. If you really, really want to make this an easier triangle to work with, some people would prefer to find this angle. This is 75. Keep in mind the three angles in a triangle need to add up to 180 degrees. So once we have that, we can use trigonometry. So we know the opposite side to the 75. We know the hypotenuse, so we can use sine. So I'm going to use that sine of 75 is equal to my F perpendicular over 882. And that gives me that my F perpendicular is equal to about 799.4 newtons. So once I know that force there, I now actually am able to find my normal force. It's equal to that. So my normal force is all I really needed. I have my, my coefficient of frictional force. So all I need to do now is just multiply those two things together. So I end up getting 0.05 times that normal force that I just found. And my final answer is going to be approximately 40 newtons.